Ooh, let's get the music back. I like the music. Where's the music? What's up, Ethan? This. My LS. Okay, I'll stop. You got the physics projectile motion question. Oh, very cool. Bonjour, Teacup. What's going on, dude? I don't know if you can see, but like I seriously sunburned my arm. I guess you can't really see because the light doesn't really make it look that bad. Yeah. I was out golfing with A-Rod earlier, and I forgot. He says, wait, put the music back. All right, I'll put the music back. Yeah, there you go. Yeah, this is that is so good. Yeah, well, this was me. This is A-Rod. This is. I'll see. I'm wearing the same shirt right now. I should use it in some conditions. Yeah, maybe it's pretty fun. Fan of the music. But yeah, I was golfing earlier. Luckily, got back just in time to stream and teach you guys some stuff. It's fun. Although I don't know if I'll be able to make Roblox today because I do have to teach another student right afterwards. They booked me like last minute. But I think to make up for it, I'll do Jackbox tomorrow in the afternoon, Saturday. Yeah. What's up, Teacup? Oh, Gold? Might not be able to attend? It's okay. You're attending right now. What do you mean not be able to attend what? Oh, at the end of July. Oh, that's totally okay. Like, I understand, like, you guys have vacations and stuff. Like, go do things with your, your family. Okay. All good. It was a hot one today. Hot. You're going to be at Disney parks from 8 until 2 a.m.? Wait, 8 a.m. to 2 a.m.? Or like 8 p.m. to 2 a.m.? You hate Jackbox? Oh.
Wait, if Ramtin is here, I can play Jackbox with the people who want like later when you're not here.
Yeah, I'm thinking. Yeah. Do you have Jackbox? Do you have Jackbox?
I do. Long time ago. I need to find the account.
I have all of them. It's on Steam somewhere. Wait, Teacup, why are you at Disney for what is that? Wait, 3 hours, 12 hours?
Well, I guess
17 hours? 17 hours at Disney, dude? What are you doing for 17 hours at Disneyland, dude? What? I like Disney. That's just one day. Oh, okay. I don't know, dude. I'd be exhausted. 17 hours at a theme park? Is there like a nap ride you can go on? Oh, there's Disney After Hours. Ooh, okay. Let's check this out. I'm curious. Didn't know about this. Oh, okay. I don't know, dude. You walk so much. Hypatia, have you ever been to Disneyland or Disney World or any of these things before?
Well, like the one in China, it's not quite, and the one in Florida, I can never go there because I'm trans.
What does Disney not like trans people? Well, I thought they do.
No,
I thought that's the whole fight with the Florida mayor, right? The "Don't Say Gay" guy or something. Yeah.
Because like it doesn't matter.
Oh, come to the California one. Dude, we love trans people over here in California.
Wait,
really.
There's a California one?
Yes. There's Disneyland. Disney World is in Florida, but Disneyland, which is the OG, by the way. Disneyland is the OG one. That's in California.
That's cool.
Yeah, it's in Los Angeles. Yeah, we can hang out. Wow. Yeah, Disneyland. Yeah, I've been twice. I went last, I think November I went on like a Tuesday or something. Yeah. But yeah, it's right down here in like Anaheim. So down in like Orange County. So like here, my house is like over here. I live over here in Santa Monica land. And then this is where Disneyland. Pretty cool. What's up, Nick? I'm doing good. I'm good. I'm a little sunburned. Okay.
Is it
Uh,
fun at Disneyland?
it is. It is. Honestly, like Disney, you know, Disney has that magic to it where like they do things very well. They theme it very well. Like I've been to other theme parks such as like Six Flags or Knott's Berry Farm and whatnot, and like they're good, but Disney has like so much attention to detail that like every individual little thing has been thought of, and it's all themed in Disneyness. Yeah, I
Well,
bet it did.
what IP do they have? Like
What
besides
IP?
besides that duck and mouse
Oh,
thing.
oh well, okay. So first of all, Disney has right Mickey Mouse. They have like Toy Story. This is actually the cool thing. Okay, well, so, you know, take a little detour from learning. Let's go over all the different parks. With Disneyland map. If you just look at a map of of Disneyland, this will tell you like what all the different theme areas are. Let's see if we can see it. Wait, I can't zoom in on this image. What? Open image in new tab. There we go. Okay, cool. All right. So this is like where you come in. This is the main street and whatnot, and they have, you know, Disney candy stores, whatever. And then this is Adventureland. So Disney owns all the Indiana Jones series. So a lot of the Indiana Jones stuff is here. Tomorrowland is where they have kind of like the more future stuff, like all the Toy Story, Buzz Lightyear stuff is here. Fantasyland, I think that's kind of like Cinderella, Beauty and the Beast, all those enterprises. Mickey's Toontown. They actually closed down Mickey's Toontown. I don't think Mickey's Toontown is open. Like I went, I don't think it was there. Yeah. Oh, Teacup says you can fit the entirety of Disneyland in the Magic Kingdom parking lot. Yeah, I'm sure. Yeah, so the whole story about this is that Walt Disney wanted to build a theme park, and he wanted it to be unlike any other theme park. So he built it in like Los Angeles first, Disneyland. And then after, I don't know, 10 years or something, he was saying, okay, I need an even bigger theme park, but I can't really do it in Los Angeles because there's not enough land. Let me go to Florida and just buy this swamp that nobody wants. and then just install like the biggest theme park ever. And that's
I think they have some kind of legal autonomy.
they used to. I know that's a fight right now, right, between the governor and yeah, it's a whole thing. But Pirates of the Caribbean, that's also Disney. And then the biggest one that they just added is Star Wars. Like Disney bought all of Star Wars, and that's huge.
Probably the only IP that I'm familiar with.
Yeah, but Star Wars is dope. Like I really do love what Disney has done with Star Wars. You know, I think they've done a lot of cool stuff with it, and I'm glad they've been the stewards of that. I guess they've really developed it pretty well.
Yeah, like there's this mathematician who said it's what's the character's name? Like Obi-Wan
Kenobi. Yeah, he's one of the Jedis.
Let me send you this mathematician's picture, and then you will see why I say that.
He looks like Obi-Wan.
Like,
too funny.
He dresses like that person.
Does he? Oh wow, that's pretty cool.
Yeah, get it.
All right, you sent it in office hours?
Yeah.
Hold up.
Look at the rightmost one.
Okay, one sec. Let me go to that, and then we turn on the Discord. Oh wow, he does look like Obi-Wan Kenobi. This guy right here on the right, yeah, this guy really does look like Obi-Wan Kenobi.
Yeah, his name is Alexander Gordon, like the founding father of modern algebraic geometry.
Wow,
also a really good
cool.
anarchist and things like that.
That's super dope. Yeah, he does look like a Jedi. I'll give him that. He probably acts like a Jedi too if he knows all the math stuff. Pretty crazy. Dark says he's never been to Disneyland. Have you been to Disney World? So Disney World is the one in Florida. That's the big one. Ethan, yeah, I know Ethan probably hasn't because Ethan's in Belize. Ethan, have you ever been to the United States? We need to get you to the United States at some point. I know you have an aunt here, right? Because I've mailed your aunt things before. Yes. Oh, there's California, Paris, Hong Kong, Hawaii, Tokyo, China, and Florida. I heard some funny things about the Disneyland in China, though. Hypatia, maybe you know about this, where like people were just like I don't know, not using the bathrooms correctly. Apparently, they were just like taking a shit in the field or something. I don't know. Apparently, like Disneyland China is kind of like the Wild West because there's so many people.
Yeah, that's not the whole like the most insane part of it.
Well, okay, tell me what's the most insane part of Disneyland China?
like basically it's not run by the Disney group.
Oh, it's not.
run by like the Communist Party subdivision of like
And
information and
Disney lets this
culture.
happen. Disney lets China run their own like theme park with the Disney name, or
Yeah,
do
I
they just
think,
like steal
for
it?
example, I see images about so like there is this fancy theme park decoration, and on the top of it there is a banner,
Uh-huh.
written like propaganda.
Oh, interesting. They put their own little. Oh, it's in Shanghai. It looks like. Yeah.
Yeah, I think also on the roadside, so like Shanghai or Beijing, they tends to put kind of propaganda banners all over the place, and somehow
Oh.
they figure out a way to incorporate whatever they have
Their
into.
propaganda into the Disney stuff. Wow, that's interesting.
Yeah.
I'm very amazed that Disney would allow that, because Disney is very protective of their intellectual property. IP is what we call it. So like they are very controlling on like what you can do with Disney stuff. But I guess
Yeah,
maybe
well,
Chinese
but
market's so big.
like a dictator.
Yeah, I guess it is. Yeah. Well, this is cool. I mean, oh, the honey pot spin. Yeah, okay, looks pretty cool. Roaring Rapids. You know, it's always nice because like, you know, they have roller coasters and whatnot, but they're not super scary or serious roller coasters. They're kind of more of like you're going through like a theme or something. Teacup says, when I get a full-time job, I'm gonna try to become a Disney Imagineer. Yeah, that'd be super cool. I think I know some people that work for Disney. I gotta remember if I do. But yeah, Disney was kind of at the forefront too, because they did a lot with robotics, right? A lot of their rides involve like what we call like animatronics, which are mechanical things that look like humans or look like, you know, different things. And so they have a lot of technology they pioneered. Also the monorail, I think the biggest monorail built in the United States at whatever time or whatnot was in Disney. There's a whole story about the monorail and how Walt Disney really loved monorails, and he wanted to build like a super big one in Disney. And so that's what gets people around the stuff. Yeah.
Also, I'm sure they also hire mathematicians too. They need computer graphics.
Yes, yeah, lots of CGI.
Researchers.
Well, because yeah, so Disney also I think owns Pixar, right? And Pixar
Really?
does. Yeah, I think Disney owns Pixar. I think it's called Disney Pixar. I know. I thought Pixar used to also be Lucasfilm at some point. Let me see.
They bought out Lucasfilm. They own the entirety of Lucasfilm.
I know, but I think Pixar. Okay, so Pixar. Yeah, Pixar is owned by Disney, but Pixar started as a part of Lucasfilm. Yeah, this is what I knew. This is what I knew. Yeah, yeah.
Like,
In
then they bought it all, and now they own
yeah, yeah. In 1979, Pixar was a part of Lucasfilm.
Wikipedia.
Pardon?
Are you on Wikipedia?
Yeah, I'm on Wikipedia right now. What's wrong with Wikipedia? Wikipedia's great.
Nah, I'm one of those teachers that if you use Wikipedia, you're gonna get an F on your Wikipedia Gold.
Oh, that's so funny. Pixar had money from Steve Jobs. Really? Wow, I didn't know Steve Jobs was involved with this too.
I have stocks in Disney.
That's cool. Yeah, Disney's a cool company. You know,
Here's
they do
gold.
a lot of cool stuff.
Watch both the things I send in chat.
Okay, I'll watch them and then let's do some math questions. All right, what'd you send? You want this? Let's see what this is. I'm gonna get an average. I don't want to discover French culture. I did meet a French girl the other night. That's kind of interesting. How do you know this? Like YouTube? What? Okay, here we go. Oh yes, the Tron ride. Oh, I want to do this one, but this one's only at
Disney World.
It's only at Disney World. Yeah.
Here's the thing. I'm gonna be riding it at 2 a.m. in the morning.
Oh, that's super dope. Oh wow, I see this. Like you go through this whole like. Oh, I love the music too. You know, like what was it? Daft Punk did a lot of the music for the newest Tron, which I really loved. What? Oh, this looks so cool.
Well, your stream is way behind.
Oh, it's okay. I mean,
on Twitch at least.
Yeah, Twitch always delays a little bit.
Oh, did you see? They're like custom lockers, but you should see like. I need to show you the queue at one point.
The queue? Yeah. Okay. So this is also the cool thing. Hypatia is okay. So most theme parks and whatnot, you wait in these lines and the lines suck and they're really long and there's nothing to really do. But in Disney, at most Disney rides, the line is like part of the experience. Like you end up going through these cool, you know, displays or whatnot, or the lines are kind of interactive.
The Fast Pass was the Genie thing, which used to be
Genie Pass. You have to get the Genie Pass. You have to get the Genie Pass.
yeah, you pretty much need to get it. But if you want to get the cool queues, you gotta go to the regular. Like Mine Train, go for the regular queue. You get to do some cool stuff.
I think they should develop an app where people just like plan their.
They have that.
You can.
They have that.
Yeah,
They
you
have
can.
that.
You can plan it, and the Genie Pass, what it does is it allows you, I think, to book things like an hour or two ahead of time or something. But you still have to be kind of on it. You can't plan the whole day ahead of itself. You know, I think. But yeah, this is cool. Okay, cool. And then what is this? Five Nights at Freddy's has a trailer now.
Oh yeah, they have a trailer. You
Okay,
can
cool.
watch
Let's watch this trailer, and then we'll start doing some math stuff. Damn, Five Nights at Freddy's pretty dope.
Hi,
Ooh.
this is Mike. I was just calling to see if that job that you offered was still available.
Yes. The security guard.
I will take anything.
Do you ever play
Oh.
Five
Place
Nights at
was
Freddy's?
huge in the 80s with
I
the
have.
kids.
Okay.
They shut it down years ago. The owner's just not ready to let it go yet.
Oh man.
Work and you will sleep.
I understand.
I have something to tell you. After
Wait, he's gonna be a security guard at this at Five Nights at Freddy's? Oh no. Oh no. Oh no. Oh no. Oh, Megan, isn't that the doll horror film?
Just keep your
Oh
eyes
yeah,
on
it's
the
from the same
monitors.
guys.
Yeah.
Welcome to Freddy Fazbear's, where fantasy and fun come to life.
Okay. Uh-oh. Oh, it's coming out on Halloween. That's too funny.
Must be new security guard.
Can I?
I think they did it
help
on
you,
purpose.
Officer?
Have you met them yet?
Oh no.
Met who?
Them.
Uh-oh, don't fall asleep with the oh god, it's jump scares. That music, dude, no.
You don't like the music?
Oh my god. He's like, turn it off.
In the 80s, kids went missing. The police searched Freddy's top to bottom.
Hello?
They never found
They
them.
never found. Oh god.
That's why the place shut down.
There are ghost children possessing giant robots.
Oh.
Thanks for the heads up.
Technically, they're
Who is this actor? I know this guy. Where's he from?
What do they want?
They want to make her like them.
Pappy! Tell me how to stop them.
It's too late.
Oh god. Yeah, no, not the eyes, dude. No. Someone's gonna get pulled. Someone's gonna get pulled by the legs. I know it's gonna happen. Let him out. Oh god.
Where to? Why do I always get the weirdos?
Alright, cool. That's dope.
Oh yeah, that was Cole and Kenshin, by the way. He's a YouTuber.
Oh,
real
okay.
quick,
Yeah, what's up?
thing about the FNAF trailer, those are actual animatronics. They're not like CGI.
Oh, they're not
That's
CGI. Those are actual like animatronics. That's very cool.
Yeah.
And that's what like the Disney Imagineer stuff does. That's him at the end. Yeah, yeah, that's cool. That's cool. Yeah, a cool YouTuber. Okay. What YouTuber is that? What's the name of the
Corey
YouTuber?
Kenshin. Corey X Kenshin, I think.
Oh, yeah, wait. I think I know that guy. Yeah, Corey. Yeah. Okay. Cool. All right, here,
But,
let's
Yeah, I think I know him.
I think I know him. Maybe I'll meet him someday. Let's start off the stream. All right. Welcome everyone to Office Hours. This is Actual Education, the stream that helps you out with your math homework, science homework, all types of fun stuff. It's Friday. I love Friday. Friday's like kind of a chill day, and it's the summer, so I'm not so hung up on us having to jump right into doing questions yet. I like to see what's going on in the world. We talked a little bit about Disney, some cool stuff.
Disney
Five Nights at
W.
Freddy's, Disney W, yeah. Yeah, nice. Okay, cool. Let's see. I posted another video on TikTok, so I'm starting to get like some more people. Ooh, we got some good questions. First question of the day. Ooh, is Ethan. What's up, Ethan? Ethan's been learning like physics on his own over the summer, which I think is very cool. I have a degree in physics. I have a PhD in physics, so I teach a lot of physics. And this looks like, ooh, this is yes, this looks like 2D projectile motion is what this is, Ethan. This is pretty cool. I have a video on this I've done like a 1D projectile motion video, but this is 2D. I have a 2D in the works. I need to edit it. I need to edit and publish it. Okay. Let's see. Ethan, are you here? You on the stage? What's up?
Hello, can you hear me?
Yes, I can hear you, Ethan. How's it going, dude?
It's going. Also,
Nice.
am I the first person to learn physics myself?
You are the first person to learn physics on your own. Yeah, that's pretty cool, dude. Really dope. Really dope. I like
That's dope.
it. Because you'll probably take physics, what, next year in high school or the year after, probably, right?
No, I'm taking it this year.
Oh, you are taking it this year. Oh, you're just learning it ahead of time over the summer. That's very cool.
Yes.
Right? That's dope. That's dope. Okay, cool. All right. Okay, this is what we call projectile motion, right? You see how it says a projectile is thrown, right? We talked earlier about like what a projectile is, right? A projectile could be like a ball or like a missile or, you know, anything.
It's something that you throw.
Yeah, something you throw, right? Yeah, it's projectile motion. Okay, cool. We're getting into projectile motion, and this is kind of like an introductory thing, which is going to be dealing with the velocities of things in what we call 2 dimensions. Okay. Do you know why it's called like 2 dimensions, Ethan?
No, I don't know why it's called 2D.
Okay, cool. All right. So when we throw something, right, you have objects that are moving in the air, right? And they can move, let's say we have like a ball here that we're throwing, right? This ball can move left and right, and it can also move up and down, right? If you throw something, right? It usually moves, you know, left, right, or up, down.
Yes, it is.
Good, okay. The reason why this is called 2 dimensions because this is what we call the horizontal direction, which is 1 dimension, okay? Usually we represent this as X. And then we have things that can go in the up-down direction, which we call the vertical direction.
Yeah, that is called vertical.
Good, okay. And this is usually represented by what we call Y, okay? And this is why this is 2D, 2 dimensions. We have things moving left, right, and up, down. Okay?
Is there any like other dimensions like 3D or 1D?
There is. So there is 3D. You experience the world in 3D, right? Because in your world, right, things don't only go left, right, up, down, right? They kind of also go like we would say into the page or out of the page.
I thought you were meaning saying like vertical, like left, like bottom left to bottom right, or sorry, bottom left to top right, something like that.
Good, yeah. So things go up and down, right? Still vertical in 3D, but then in the horizontal direction, you know how you can go north or you can go west or east or south, right? That's the other 2 dimensions.
Yeah, what if you go like southwest? What if it's that? Then that would be a different direction, right?
Yeah, exactly. Here, so I'll show you. So, like for instance, this would be like the up-down dimension. Okay, I'm gonna show you like what movement in 3D looks like, which is pretty cool. And then what you have is you have stuff that can go in what we call like the X and Y plane, is what it is. You see how this is kind of like almost like a sheet of paper, like a plate, right? And objects, okay, right, can move around here, right? But they can also move up and down. So that's why there are 3 dimensions. Because I can move things left, right. I can move things along the y-axis here. We would say like into the page, out of the page, kind of per se. And then you can move things up and down.
Okay.
Okay. But don't worry about 3D stuff for now because that's way more advanced, and it's for the majority of like high school and college physics, you're really just going to deal with things in 2 dimensions. Okay.
What about 4D?
4D, yeah, this is, you know, if you were watching the stream, yes, you saw
4D.
You saw yesterday when like Hypatia and Ramton were talking about 24 dimensions and 8 dimensions and whatnot, right?
I didn't hear that. I was attending the stream, but I was just only watching.
It's okay. Yeah. So Ramton and Hypatia were talking about when you get to more modern math studies and more like complex topics, you get into dimensions that are more than 3D. Like you get into what's called E8, I think, which is 8-dimensional space. And then there's 24-dimensional space. And these are things you can't really think about in like real world terms, or at least I can't. But they do exist, I guess. But yeah, okay. So, but for now, okay, we're talking about a projectile in this problem, which is being fired at an angle, right, of 63 degrees above the horizontal, okay? So let's kind of like try to draw what that is. So let's say, for instance, I had my ball here and I fired it at 0 degrees above the horizontal, okay? This is the axis that they call the horizontal, okay? And so this arrow here, Ethan, which is technically what we call a vector, this would be like the velocity, okay?
So say, isn't that like intersecting in the x and the y axis?
Good, yeah.
Or
Yeah, this is where like it starts, right? So, for instance, if I have my ball here, Ethan, right, this red ball, right, I can launch it at different angles, right? I could launch the ball just straight to the left and right, right? That would be launching at an angle of 0 degrees, okay?
What if you launch it up? Then that's 90 degrees.
Good, yes, yes, very good. Launching it up and down is launching with an angle of 90 degrees, okay? But then there's like, what if I do something in between, right? What if I launch it to left and right and up and down?
Wouldn't that be 45 degrees then?
Yeah, good. Yeah, this would be some amount. I mean, sure, this could be like 35 degrees if we want it to be, right? In this case, they say it's what do they say? They say it's 63 degrees. So 63 degrees is probably more like, and this is the cool thing. You can take a protractor if you want to like look at it. 63 degrees is, yeah, okay. So probably like this much.
Dr. Go?
What's up?
You need protractors for physics?
I mean, if I want to draw things correctly, do you see how I'm using a protractor here to get like what around 63 degrees is? This is actually probably like 64, but yeah.
Oh gosh, I might be dead already.
No, this is okay. This is pretty cool. Protractors are really cool, and you may end up using them in class, or you may not. But you can honestly eyeball this. I'm just showing that we have tools. This is how you would use a protractor to figure out what 63. What's up, Noise?
You know how a protractor even works, because I barely use that thing.
Oh, it's okay. No, here. Well, I mean, I can show you how a protractor works. So what this is, do you see how there's a center here, right? And
That's
you see
the point.
Good, yes. And do you see how there are numbers in blue, right?
Yes, isn't that like I know the basics, like there's one going right, which is going bigger, and then the other's going left, which is also bigger.
Right, but see, yeah, so the one in the black goes from 0 to 180, and that goes clockwise, right? You see how that starts on the left and goes all the way to the right?
Yes, and then the one in blue, which is from right to left, goes anti-clockwise.
Right, yeah, that goes from the right, the blue, that goes from 0 to 180, but right to left, right? It all just depends, it depends where you're measuring your angle from. So this is actually a very other cool concept. So if I put my center of the protractor right here, okay, and that's my pink line, what angle does that look like? Like where is that angle in the blue region? What would we call that?
65 degrees?
Yeah, it's very close to 65 degrees, right? I'm just gonna say it's 63. You know, like let's just say it's 63 because that's what the question says. Okay.
Okay.
You're right. I tried to draw it as close as I could, but let's just say it's 63 degrees. Okay. And then if you want to look to see, for instance, what this angle is, Ethan, like the green one.
Hey, can I say something?
Yeah, what's up?
On the website that I got this from, it said that 63 degrees is the answer.
Yes. Yeah. But I'm gonna change the question to like show you some more parts of it. Yeah, that's a very simple answer, very simple question, but yeah, it's good. What's up?
Remember, I don't understand this, so I don't know if it's simple or not.
No, I'll show you. It's all good. Yeah, you're good because you're bringing me like introductory questions that I can then use to teach you concepts, to then ask you different things that will allow you to learn about physics. You know, sure, the answer is just 63 degrees, but like the knowledge you get from learning all the things around that is worth more. That makes sense, right?
Okay.
So if that pink angle there is 63 degrees, right? Do you see how the green angle I could measure using the black numbers?
So yeah, I can.
Yeah. So like, do you see how like that would probably be like what? What would the angle be using the black numbers? You said using the red ones, it's about 65. What would it be using the black ones?
In this case, since it's 63, I will probably make a guess about 117.
Good. Yeah, very good. Yeah. This one is 117. And you should notice something very cool here. What happens with these two angles when I add them together? What do I get?
They get you 180 degrees.
Yes.
180.
Yes. Yes, this is very important. So what we're expressing here, Ethan, is that, okay, angles, right, are measured from one axis, but if you want to measure it from the other axis, or from the other side of the same axis, that those two angles need to add up to 180, because that's the amount of degrees in a line, I guess. Okay.
Okay.
All right. So ball is launched at an angle of 63 degrees, and then they give you a speed right here, which is pretty useful. That's 100 meters per second. Okay.
Wait, it matters if they give you a speed or not?
It doesn't for this exact question, but I'm going to show you why it would matter for other questions. Okay. They give you a speed, they give you an angle, right? And then they say calculate the direction of the velocity above the horizontal at t equals 10. Oh, at t equals 10 seconds, express your... This is actually more complicated than than it is. Here, I'll show you why, though. It's pretty cool. Okay? This is a very good question, Ethan. And it's not just 63 degrees just because this says it's 63 degrees. Like, it's not. I'm going to show you why. Okay?
Okay.
Okay. So, this velocity, right, Ethan, points both up, down, and left, right. Okay? That make sense?
Yeah, it does. It does.
Okay. We're going to use one of our kinematics equations that you learned in order to calculate what the velocity is 10 seconds later. Okay? And I'm going to use this equation, which says that VF is equal to VI plus A times T. Okay? Do you remember this one from the kinematics equations?
Yeah.
Good. So let's remember that T here is the time. A is which will be 10. Very good. A is the acceleration.
V is initial velocity.
Very good.
And then V is final velocity.
Good. Very good. Very good. Okay, cool. Now, I know what you'd like to do, right? You would like to just put in 100 here for the initial, something in for A, and then plug in for 10, and then you'd get the final, right?
Yeah.
Yeah. The reason why you can't do that is because these equations are specific to what direction you're looking at. You can't have them being used in something that has velocities in both directions. So what I mean by that is, so Ethan, this ball, right, has a velocity at an angle, okay? Which means that part of its velocity is in the horizontal direction, and part of its velocity is in the vertical direction. Okay?
Okay.
These equations are only for one dimension, which means you can only use them for a single direction. This ball moves in two different directions. The velocity has what we say two components. Okay? Components is the big word here. So what we want to do first, Ethan, is we want to break down this velocity into what we call components. And components means I want to know what part of this velocity is pointing from the left to the right, okay? So this is what we would call, for instance, Vx. And I want to know which part of this velocity is pointing in the up-down direction, okay? And this is what we would call Vy.
Wait, why would you call these Vx and Vy?
Very good. Okay, so the reason why we call them Vx and Vy, Ethan, is because Vx is the part of the velocity that points in the x direction, and Vy is the part of the velocity that points in the y direction. Does that make sense so far? It's okay if it doesn't. Like, let me know.
It does. Wait.
Okay.
Don't tell me we're using Pythagoras' theorem for this.
Yes. We're gonna use.
Gave it away easily.
I know. So this is why, like, you know, when you guys like talk about math and you're like, why the hell am I learning all this stuff? Like, this is why, because you end up using things like trig functions and Pythagorean identities, whatever. You use them in all your other classes as well. In this case, you use it in physics.
I
very
mean,
related.
look, they all say this, but physics has a lot to do with math. So
It
don't
does.
don't get done.
Can't skip the math. Yeah, exactly. Okay, good. All right. So I know this 100 meters per second points in this diagonal direction, but I want to break that velocity up into the amount that points to the left, right, and the amount that points up, down. Do you see it?
I see what we're doing here.
Good.
It's like we already have the angle, okay?
Yes.
So we just gotta label the sides and then use sine, cosine, or tangent. I get it.
Yes, exactly, dude. You got it, man. Okay, so how would I figure out what Vx is?
Okay. Well, when I'm looking at this, it's the adjacent. It's the adjacent already.
Very good, very good. Yeah, this is the adjacent.
The Vy is the opposite, and the 100 is the 100 thing. There is the hypotenuse.
Nice.
Yes, exactly, dude. Very good. Okay.
And so now you want to use sine, cosine, or tangent to figure it out.
Very
So
good.
I think cosine. Cosine is better because it has adjacent and the hypotenuse.
Good, very good. Okay. So you're going to say what? Cosine.
So it's like, you're gonna say the cosine of an angle is equal to the adjacent over the hypotenuse.
Good. So the cosine of the angle, 63 degrees, is equal to the adjacent, which what's the adjacent?
Adjacent, which is Vx.
Very good.
That is over 100.
Very good. Nice, dude. Yes. Good. Do you see how you can solve for Vx now?
I mean, I don't know how you can do that right now. You can figure out cosine of 63 degrees.
Now, yeah, don't worry. We don't need the numbers yet. How do I get rid of this 100?
You multiply 100 on both sides to cancel it out.
Yes, yes, dude. Multiply by 100. Very good, Ethan. Multiply by 100, right? So now I get that Vx is equal to 100 cosine of 63 degrees. Okay.
And then you gotta figure out what's cosine of 63 degrees.
Yes. Yeah, we can do that. Here, I'll get it for you. Where is it?
Why can't these be calculated in your head?
Sorry, what? Why can't they be what?
Why can't these be calculated manually?
Because cosine of 63 degrees is not a nice angle. If it was cosine of 60 degrees, I could do it manually, but 63 is not a nice number.
I like 60 since it's my favorite number.
60 is your favorite number? That's cool. Yeah, the cosine of 60 is 1/2, so this would just become 50. You see how this just becomes 50?
Wow, that is a nice number.
It is a nice number, yeah, but unfortunately the question gave it as 63, so watch what happens when we make it 63. It's like, ew.
Oh, yeah. Wait, why is it less than the 60?
Good question. Because cosine measures the amount that is, so cosine measures this amount, right? Okay. So look what happens as this angle here, or here, let's go down here real quick. This is actually kind of a cool thing. Okay, if I have, for instance, an angle, right? Let's say this is like 30 degrees to start with, right? You remember that cosine of theta is equal to the adjacent over the hypotenuse, right?
Yeah.
So if this is the triangle, right? Then this much right here, this is what the adjacent is of that angle, right? This is the adjacent. Okay?
Yes.
Okay. Now look what happens, Ethan, as that line gets even steeper. Let's say the line is like this steep. Let's say now it's like, I don't know, like 80 degrees. You see how the amount of the adjacent now goes down? Now it's only like this much.
Where? How much? How much?
It's only this much. Yeah, like if I were to like draw this down, right? The adjacent is now less.
Okay.
Yes. This is why the angle is going up, but the adjacent is going down. So the cosine, right, which is the adjacent over the hypotenuse, that goes down as well. As you get closer and closer to here. Yeah. Cool?
Yeah, it's cool.
Cool. All right. I have a really good animation on this actually on TikTok. One sec. Let me just pull it up actually. It's actually pretty good. Just bear with me real quick. It is where's my come on, show me all my TikTok videos. I have more. There we go. Okay, cool. Here we go.
Here's a cool way to remember.
We don't need the audio. Okay. Can I just skip through this though? Care about this. Okay, so here, the blue here is like the adjacent is what it is, okay? And I think what I show is that as this angle changes, do you see how as the angle is getting bigger, the adjacent, the blue is getting smaller, but the red, the opposite, is getting bigger?
Oh, I'm seeing that.
Yeah. And that's why, so sine goes up, but cosine goes down.
Wait, why does the green get bigger?
No, the green stays the same. The green is this is a circle. It's called a unit circle because it has a radius of 1. And so the green always stays the same. That's what we say. Oh, there is a timer on this thing. Move it. Yeah, so
Okay.
as we move around the circle, the radius always stays the same. That's the green. That's the hypotenuse. But the opposite and the adjacent change. It's pretty cool. Yeah, watch these videos sometime if you want to see like what all the sine and cosine stuff is. It's pretty cool.
Sadly, I don't have TikTok. Okay.
Oh, well, it's on YouTube as well. You can find it on YouTube.
Okay.
Okay. All right, cool. So we found the x component, right? That was 100 cosine of 63 degrees, which when we did it on the calculator, that was what, 45.4, right?
It has 45.79.
Yeah, we'll just round it to 1 decimal place. We're going to say 45.4, and that's going to be meters per second, okay?
Okay.
All right, let's try to figure out Vy. How do I get Vy now?
Okay, I think you have to use a different one, not cosine.
You do. Good.
Okay, so I think I would use tangent since we've already found.
We could use tangent. That's okay. We can use it. Tangent,
But
right?
when I'm looking at this one right now, it has a decimal, which I feel uncomfortable with.
That's okay. Then so let's not use tangent. What's another one we can use that has the opposite in it somewhere?
Sine. We have the sine.
Sine. Right. Good. So you know that the sine of 63 degrees. You guys call it sin? Really?
Sometimes. We sometimes call it sin.
Oh, that's interesting. Well,
Yeah.
I guess people. It's weird because we will sometimes spell sine as this, but then when we use it in math, we just spell it as sin. I don't know why that is. Noise, what do they say in the UK? Is it sin or sine? I want to know what they do in England. That's pretty funny. Okay. So this is the sine of 63 degrees is equal to what?
Let me tell you what they call it in China.
Yeah, what do they call it in China? What do they call it in China?
Like sine is 正弦. It means like orthogonal or regular arc or regular chord.
Or like normal, right? We call that normal here. If something's perpendicular, we say it's normal.
Yeah, and then the cosine is called 余弦 residual chord or residual arc or something.
Residual arc. Oh, that's so cool.
Because residual, so if something has a ko in front of it, mathematicians usually translate it as 余 or 上, like so. Residual or like the direction up, I guess. We don't really. Well, it comes from the notation for that, and then 正弦, and I forgot what tangent was called.
Yeah, tangent must be a weird one, right? Can't imagine tangent.
I don't understand any of what he just said.
Yeah, he's saying they use in China they use different words for sine and cosine, and they're more related to the math terms. Because you'll see here. Okay, so sine is which one? It's what over what?
Sine is the opposite over the hypotenuse.
Good, the opposite, right? Which is Vy over 100. Now, this opposite right here, Ethan, do you see how this opposite makes a 90-degree angle with this, right?
Yes, I see that.
So in math, when things are 90 degrees to things, we have a couple words for that. So we have perpendicular. You've heard that word before, right?
Isn't that when two lines? No, that's not when two. Isn't that when they intersect?
They do intersect, but when they intersect at a 90-degree angle, things are perpendicular. The other word we can use is normal. Normal is another word that kind of means 90 degrees. And then the one that Hypatia was saying that's a little bit more complex is called orthogonal. Orthogonal also means 90 degrees. But I think orthogonal means like 90 degrees in 3 dimensions, right? It's like
orthogonal. It means the in some kind of vanishing of inner product.
Okay, there you go. Vanishing of inner product.
You have two vectors. do an inner product dot product,
Yes.
it becomes 0,
And it goes to 0.
they are orthogonal.
Ah.
Or like say if you are on a Riemannian manifold, you have two tangent vectors, and then they have inner product 0. That means the two curves are orthogonal at that point.
Oh, that's very cool. Oh, yeah. Okay. Yeah, there's all sorts of, yeah, okay. I've always like kind of wondered what the difference is. Yeah, that makes sense. We'll talk about it later, Ethan, inner products and stuff. That has to do with dot products. But okay. So we got here. So how do we figure out what Vy is?
You multiply 100 by 105, right?
Good. So this is 100 sine of 63 degrees. Okay.
Yes. And then
that's-
you do the same thing.
Yeah, we got to do the calculations. Okay. Not the
Wait, we already have that.
Sorry?
We already have the cosine of 63 degrees.
But now we need the sine of 63 degrees.
Oh, I forgot. It's different.
It is. It's okay. 100 sine of 63 is now 89.1. Okay.
Oh, that's bigger.
That is bigger. Yep. And that makes sense, right? Because if this thing is at a high angle, right, there's more up, down than there is left, right. You know? If this thing was at 90 degrees, like if this thing was like straight up, then there would be no, left, right. And there would only be up, down.
Okay.
Okay, good. And this is something I want you to notice, Ethan. If you are ever calculating the velocity in one direction and you get like cosine or sine, the other direction will always be the opposite of it. So if this one is cosine, the other one will be sine. If this one was sine, the other one will be cosine. It's just, what about tangent?
Yeah. Will there be an opposite for that?
No, not really. We don't really use tangent for breaking down components. I don't think so. Yeah, no, not really. Don't worry about tangent in physics. You don't really need it. Well, you will at the end. I'm going to show you why you do need it at the very end. But yeah, for now. Okay. Okay, so these are our velocities, Ethan. Okay, so now we've taken this 100, which was an initial velocity in both the x and y direction, and we've broken it up into initial velocities in just the x direction and just the y direction. Okay?
All right. So what now?
Good. So now we need to do the math, okay? Because I want to know what happens to these velocities, okay, after 10 seconds. Okay?
How can you determine that?
Good. So what we're going to use, Ethan, is we're going to use this formula, okay? So we are now allowed to use this formula because we're dealing with velocities only in the x direction and only in the y direction. Like, they're separated. They're in different directions. Okay. So how this is usually written here, Ethan, is I would say that VFX is equal to VIX plus AX times T. Okay. The X here signifies what direction I'm looking at. Okay.
What if you use Y? Would that work?
Good. That's what we're going to use for the next one. So when we want to figure out what happens to the Y direction, we're going to say VFY is equal to VIY plus AY times T.
All right, so let's do the X one then.
Yeah, let's do it. Okay, so I'm trying to figure out what the final velocity in the X direction is. Okay, so this is what we're trying to figure out. I know what the initial velocity in the X direction is. Which one is that?
Isn't that 10 seconds?
No. So the initial velocity is what is the starting velocity of this object in the X direction?
Can I see the question if that has the answer?
Well, okay, so let's remember, the initial velocity was 100, right? But that pointed in both the X and Y direction. What did we do here, Ethan? What was this 45.4?
This is the answer that we got in meters per second.
Good, but why did we get this? Like, what does this 45.4 mean compared to the 100?
Oh, I think it's the initial velocity, right? Like
Good.
half of it?
It's the initial velocity in the X direction. It's how much of this 100 is pointing just left and right. Okay? This 100 is at an angle. And the 45.4 is just the amount of that 100 that points left and right. Okay?
All right.
So this is going to be 45.4. Okay?
All right.
All right? And then the next thing we need to know is we need to know what the acceleration is in the X direction. Okay?
Is that still unknown?
That is 0. And I'll explain why. So this goes to another physics concept I don't think you've learned yet, which is that F equals ma. Have you seen this before?
I don't think I literally don't know anything about physics, so I wouldn't know anything.
It's okay.
I wouldn't know much.
So what this basically says is that in order for there to be acceleration for something, there needs to be a force on it. Okay?
Okay, a force on it, what? That you gotta push this thing to accelerate it?
Exactly, yes, okay. So if this thing is in the air, okay, is there anything pushing it to the left and right if it's just in the air, just chilling?
No.
No, right? Good. So the so if the force is 0, okay, so is the acceleration. That's what we say.
Happens?
Pardon?
What's with the M then?
Oh, the M is just the mass, but that doesn't matter, right? This is just how heavy the thing is, you know. And so, 0 is equal to M times 0, right? The mass can't be 0. So what happens here, Ethan, is we say that the acceleration in the x direction is 0. So we get rid of that, okay?
Wait, what about the t then?
Doesn't matter what t is. T is technically 10, but let's remember that ax is 0, and 0 times anything is 0, unless it's infinity.
Oh,
Okay. So this is just gonna go away. What?
What is 0 times infinity then?
Oh, we can go into that later. That's undefined technically.
Oh, okay.
Don't worry about that. I'm just like covering my, you know, my bases. Okay, so if this is gone, right? What does that tell me my final velocity in the x direction is after 10 seconds?
Look, I don't know.
Well, let's look. VFX is equal to VIX. VIX is 45.4. So what is VFX?
45.4 still?
Yes. This is a very important concept here. Very important concept. The velocity in the x direction, Ethan, does not change. It has not changed. Okay? After 10 seconds.
Wait, I thought it would change.
It doesn't. In the x direction, it does not. When we go looking at the y direction, it will, but in the x direction, it does not, because there is no force on it in the x direction.
Okay.
Okay. All right. So now let's look at the y direction. This is gonna be a little bit different. Okay. So again, this is what we're looking for. What is VIY?
We already know it's 89.1 meters per second.
Very good. Okay. Now here comes the tricky part. Do you know what the acceleration in the y direction is?
Of course not.
Okay. Any object that is in the air, and what we say like free falling, like it's just chilling in the air and whatnot, always experiences a force of gravity pulling it down. Okay?
What?
So any object in the air, right? You know, it wants to fall down, right? In the up-down direction. Yeah. That's because gravity, the force of gravity, pulls things towards the ground. Okay?
Yeah. It's like when you jump, right, and then you just go back down.
Exactly. That's because gravity is pulling you down, and what that means is that the acceleration in the y direction, right, the up and down direction, is always going to be negative 9.8 meters per second squared. This is what we call the acceleration due to gravity.
Wait, it's always going to be that?
Yes. Yes. Gravity. Well, if you're on the Earth, at least.
Oh, if you're in space, then what?
It's different. Depends on things. Like I think on the moon the acceleration due to gravity is like 1.7 or something. It's less. That's why people jump really funny on the moon. Have you seen those videos before of like people jumping on the moon?
Yeah. Also, I saw on the website as well where if you check out the answer, it has like due to gravity 9.8 meters per second. Meters per second. I didn't get that.
Yeah, here, 1 second. I'll show you. So this is footage of people. Do you see how they're floating almost in the air, right?
Yes, this is different gravity though.
Yes, this is because the acceleration due to gravity on the moon is less. Okay? And because it's less, it doesn't pull you down as quickly.
See, they have like low gravity in space.
Yes. Yeah, acceleration.
Also, what about high gravity? Does that exist here?
Oh, it is 1.6. It's 1.6. Yeah, that's what I thought it was. 1.6.
Also,
what's up?
Do they have high gravity in the real world? Like I've heard of that.
Yeah, high gravity. Yeah, high gravity exists. So for instance, Yeah. If you were on a heavier planet, then you would have heavier gravity. So for instance, if you're on Jupiter,
Oh, Jupiter, the biggest planet.
one of the biggest.
One of the biggest?
Is it the biggest? Is Jupiter the biggest planet in our solar system? I don't know. It's a good question, actually.
They say that.
Oh, you're right. It is Jupiter. That's cool. Oh, Saturn's close. All right, cool. Good to know. I learned something every day.
Also, what is Neptune? Is that a planet or not? I'm wondering of that question.
Is Pluto a planet?
Oh yeah, Pluto, not Neptune. But I'm wondering if Pluto is a planet because it's just saying.
I think it's been debated recently on like whether it's a planet or not. I think they removed it as a planet, and they say it's like a orbiting body or something.
Okay, fine.
It's okay. People just come up with definitions. All right, but anyways, back to the question here. Okay, here's our initial velocity. The acceleration I'm gonna put in, that's gonna be negative 9.8. Okay.
Okay. Wait, why negative?
Because it's pulling you down. Negative is down. Acceleration is down.
Right.
Gravity pulls you down. And then what am I going to put in for the time?
We all know that it's 10 seconds.
Good, very good. Okay, awesome. So, I'm now going to solve this, right? So this is 89.1 plus, and then this is going to be negative 9.8 times 10. Okay?
Isn't that just negative 9.80?
Yes, negative 9.8. No, it's negative 98. So the 10...
Oh, right,
moves
yeah.
the decimal, so this is actually negative 98. So this becomes 89.1 minus 98, okay? Which, calculator out. My Discord.
I think it's negative 9.9.
Yeah, it probably is. 89.1 minus 98. Good, is negative 8.9. Okay, cool. So this is now... Good, this is our final velocity in the y direction, okay? All right. Okay. Now they want to know. So this is our final velocity in both x and y. Okay, but we can represent this velocity as a single velocity, and I'll show you how. Okay, so let's draw like our little coordinate axis here, right? Okay, I know that this velocity, right, points. Here, let me get a bigger arrow for this. I need a bigger arrow. Points at 45.4 in the x direction, right? That's what we figured out.
Okay.
And then it also points negative 8.9 in the y direction. Okay.
Why didn't you do the other line, the down line?
I could have drawn it here as well. Yeah, we could do this, but I like to do it this way. I'll show you why. Okay.
I'd rather have it the left way.
Yeah, well, you want to do it this way because what we're now going to get, which is called the resultant velocity, resultant vector, is this. So this is what is similar to what we did over here. Do you remember? You remember here where I broke up this 100 into both y and x? Okay.
So now we're breaking up these two into whatever.
So now we're building it back. Is what we're doing. So we're building it back from this into one of these.
So you're telling me we're doing Pythagorean theorem again?
Yes. Yes. Very good. Yeah. Very good. Yeah. So how do we figure out this?
Wow. You gotta add them or subtract them.
Well, no. You gotta square them, right?
You gotta square them. It's like a squared plus b squared is equal to c squared.
Very good. Very good. Equals c squared, right? So I'm gonna square these two, and then I'm gonna add them. Okay. So I'm gonna do.
I think the first one is like let me try to think. I think it's like.
Yeah, you try to do it. You try to do it.
Wait, what are you doing? I don't get that. How are you able to do all of that stuff?
Okay. Here's what I'm doing. Okay, so what I did is, let's do the first thing, right? 45.4 squared.
Okay.
That's that number, right? And then I'm going to add that to the negative 8.9 squared. Okay? Make sure you put the parentheses around the negative, otherwise this screws up. Okay?
Yeah, but wait. Why around the negative?
Because I need to square the whole number, right? And if I do negative 8.9 times negative 8.9, the negatives will cancel each other out, right?
Yes, but then that still applies to that because you're still multiplying them and
Good. So
positive.
it's a positive number, right? But look what happens in the calculator. If you, for instance, do this, do you see how I have just negative 8.9 squared right here?
Yeah.
See how that gets you a negative number?
That doesn't make sense there.
Yeah, that's wrong. Yeah. Because what it's doing is it's multiplying 8.9 by 8.9 and then it's putting the negative on it. That's what the calculator's doing. Which is wrong.
Yeah, wrong.
Okay. That's why we put the parentheses around it. Okay. So we added that. So that gets us 2140.37 is equal to c squared, right? So what's the last step I do here?
Square root both sides.
Yes. So I'm going to do square root of that big number there, okay? And that's going to get me 46.26, or let's say 46.3, okay?
All right, so what now? Is that it?
Good. So that's the velocity. The velocity is 46.3 meters per second, okay?
For the ball?
Yes. The ball is moving at a speed of 46.3 meters per second after 10 seconds, okay? But the last part, the thing they wanted the direction, okay? Which means they want an angle, which, Ethan, means that they want this angle right here. They want to know what this is.
I'm just wondering about this now because when I was in second form, or well, in the next, like last year or this year, we had the angles. We actually had to find the angles as well.
Good. Yeah, there's a way to do this.
The way I think that it happened was by using one of the three things, like sine, cosine, or tangent.
Yeah. So you could do what's called like a inverse trig function is what you can use. Okay.
Inverse trig function.
Yeah, I'll show you how. Okay. So pick any of them. Pick any of the trig functions. You can pick whatever you want. It's actually okay.
Okay, I want sin.
Tangent? You want to do tangent?
I said sin. Sine.
Okay, sin. Okay. So the sine of theta, right, is equal to, we know, the opposite. What's the opposite here?
The opposite is the negative 8.9.
Negative 8.9. Okay, cool. And what's the hypotenuse?
Whatever that is.
This right here, right?
Yeah.
46.3?
Yes.
Okay.
And then I think you can actually just solve that immediately since those two are identified.
Yes. Good. So how do I? So yeah, I can get a number for this, right? If I really want to. What is that? That's negative 8.9 divided by 46.3. Oh yeah, let me put it on the screen. My bad. Got it. So that's negative 0.192. We have the sine of theta is equal to negative 0.192. Okay.
Okay.
How do I get this? I want to get rid of the sine. Do you know how to get rid of the sine?
Don't you divide it by both sides?
You can't divide by sine, unfortunately. It doesn't really work. What you can do, you can act an inverse trig function on it, is what you say.
You mean turn that sine to like sine of -1?
So here's what we're gonna do. I'm gonna do the sine of -1 on both sides. That's what I'm gonna do. Okay, watch this. Sine -1 of this. Okay.
Usually what the teacher would do is just put the sign on the other side and just have that as a -1.
Yeah, I know. But I'm going to show you how this works, okay? So, when these two things, when sine of -1 and sine see each other, they like destroy each other. So this goes away, and you're just left with theta.
Is it just like when it's like two people are fighting and then they just knock each other out?
Yeah, exactly, yeah. Like, or when Noise decides to take 1v8. Don't worry, Teacup. I'm going to do your question next. Don't worry. There's a lot to this question, which, Teacup, I hope you're following along. This is a very good question for physics stuff that you're going to get into later. Like, there's a lot of good concepts here that you should be learning. But yeah, I will do it. Okay. So, yeah, how this works is because, like, for the same reason, if you have, for instance, 5 inverse times 5, this just gets you 1.
And why does that happen despite the fact that there's a literal -1 there?
Because 5 to the -1 is the same thing as 1 over 5 times 5.
Isn't that just, let me think. Isn't that like -5 And now I thought
No,
I thought it was like
negative exponents flip it is what they do. Okay.
Oh, right, yes. So it's like you're saying 1 over sign.
Yes. Kind of, but yes, in a way. Yeah, sure. The main thing is that like when inverse sine hits sine, it gets rid of it, and you just get theta. Okay. And then on this side, right, you have the sine inverse.
You want to figure out the you want to calculate out the
Yeah,
calculator
exactly.
first.
We can do that. So we're gonna do, and first let me make sure I'm in degree mode. Okay, good. Okay, so I'm gonna do the inverse sine. What's up?
Imagine as if you weren't in degree mode this whole time, then your information would be inaccurate.
Well, it would be in radians, which isn't terrible, but yes. Okay, cool.
Radiant. Then what about gradients or whatever that is?
We can get into that. That's a whole other thing. We'll get into that another time. Okay. So this gets me negative 11.1 degrees, which makes sense. Negative degrees kind of point down, is what we say. Okay. So I would actually call this 11.1 degrees.
Wait, why not the negative?
Because it's kind of already, what I'm going to say is it's 11 degrees below the horizontal, which is the same thing as saying negative 11 degrees.
Okay.
Okay. So then this is your final answer. This is 11 degrees, and you're done.
Also, I thought the answer was actually 63 degrees.
Well, I think that's wrong.
Yeah.
It's okay.
So.
I think the answer is, yeah, I think we're correct. Yeah, unless this was 10 meters per second, maybe, but I don't think so. Yeah, I think the answer is 11. It's 11 degrees. Very cool. That's an excellent question, Ethan, because like that involves a lot of concepts that are probably like new to you, but also new to other people. Like other people should know these concepts or at least be learning them. So,
Wait, that's a good one thing.
What's up?
I was looking at the wrong one. It was like it's saying that the answer is 11.24 degrees, not 11.1.
That's okay. It's just some rounding. We had some rounding errors. It's okay. That's close enough. Nice. Sweet. Good job. All right. That's a great question, Ethan. I like that. Yeah, bring me more questions like that. We'll teach you a lot of physics. Cool.
Maybe that's like the longest question I've ever had. Took us almost like an hour to do that.
Yeah, it's okay, but we learned a lot. There was a lot of like what I say side learning along the way on that question, which is great. I love questions that teach other concepts as well.
I'm glad I'm learning science.
What's up?
I'm glad I'm learning some different science and math at the same time.
Yeah, exactly. That's great.
All
right.
How is it related to science then? Because I'm also seeing math.
How's it? What? Sorry.
How's it related to science then? Since it's on the science topic, how is it related to mostly math?
Well, so the science that was in there was, for instance, us determining, right, that like the acceleration due to gravity is negative 9.8. That's science. That the acceleration is proportional to the force. That's also science. Yeah, there's science and math, but there's a lot of science in that too. You know.
It's like a half science, half math thing.
It is. It is. Okay, awesome. Let's wrap up one more question. Then I have to go teach. Teacup, what's up? You here? Teacup. Yep. Bonjour, Teacup. What's up, dude? I see you in... There you are. Yeah. Okay, Teacup. All right, cool. All right. Yeah, this is a good question. This is calculus is what this is, which is cool. Okay. They're saying find the area enclosed in the graphs y equals x to the fourth minus 12 and y equals 8 minus x squared. Okay. I have to remember what x to the fourth looks like. I think it's just something. That is not a straight line. Okay, here we go. All right. So we have x to the fourth minus 12, which I believe will look something probably like this-ish, but like probably like much steeper, I'm guessing, is what it is. Okay. This would be x to the fourth minus 12. Okay. And then we have another function, which is 8 minus x squared, which is probably going to look something like this. Okay? That makes sense so far?
Yes, hi.
Yeah, can you hear me? Yeah, good?
Yes.
Yes. Yes, he says. I know, it's 9 o'clock for you. It's getting late. Okay. All right. If I want to find the area between these two graphs, I want to find this teacup, right?
Mhm.
The way to do this is to do an integral from what we say is like A to B, okay, where this is going to be A and this is going to be B.
Yes.
And then we're going to do the top function. So I usually call this like f top. And then we say minus the bottom function. Like f bottom. Okay. And then it's all that dx. Okay. This is the equation for it. I'll go into another time like where this comes from, but it's a very useful one to know. Okay?
Mm-hmm.
So the first thing I need to do is I need to figure out where my starting point and my end points are. Okay. Do you know how to figure out where your starting point and end points are?
The highest point and lowest point. I don't know.
Okay. So let's say A and B, right, is where these two graphs intersect. You see that?
Yes.
Okay. So if I want to figure out where this is, what I'm going to do, Teacup, is I'm going to set this equation equal to this equation. Okay?
Yes.
So watch what happens. Yeah, Bob's wondering, can we do this without a calculator? We shall see, Bob. I hope it's
Go
some
to
nice
the
numbers.
calculator person.
No, I like the calculator. I took the calculator to, my high school prom, but
Yeah, you said multiple times.
I have to remind it for everyone who doesn't know that. Yeah.
Yo, remind everyone that you're in a closet.
Yeah, I am in the closet. I'm stuck in the closet.
Yeah, I'm gonna send them your address real quick.
Oh my god, stop, no.
Yo, you can have this floor plan too. Here's the zero listing.
All right, so here's what we do. We set, Bob, you see this? Yeah, we set this one equal to this one, okay? And then hopefully it turns into something nice, which I think it does. Because this
Probably
becomes
does.
x to the 4th plus x squared, and then if I minus 8 here, right, this becomes minus 20. Pretty cool.
Magic.
And then this equals 0. Right? Okay.
Yes.
Something very cool here. So do you see how I have something to the 4th power and then something to the 2nd power?
Yes.
This would be much nicer, right, if it was something to the 2nd power and something to the 1st power?
Why?
Because then it's a quadratic.
Oh, I hate quadratics.
Yeah, exactly. So this is a cool thing I'm going to do. I'm going to say let x squared equal a, which
Let
means
x
that
to the 4th equal x to the square.
x to the 4th equals a squared. Do you see that?
Oh, it was actually not wrong.
Yeah, no, it's a cool. So instead of writing this, I'm going to write a squared. Instead of writing this, I'm going to write a, and then I can leave it.
It equals
This is-
square.
This is minus 20. Who cares? Okay. This is something I can factor now. Okay. Let's try. This is a nice quadratic, right? How can I factor this?
Let's see.
Yeah, you didn't know that, Bob? Yeah, this is a very cool trick. Yeah. If you ever see Bob, if you see stuff where it's like they're decreasing powers by factors of 2. So for instance, if I had like x to the 6th plus x to the 3rd, same shit. You make this equal to a, and then this is a squared.
Oh,
If-
this is a trinomial.
This is a perfect square trinomial. Not a perfect square, sorry, but
Square.
it is a trinomial because it's got 3 terms. But this is easy, right? What two
Yes.
things multiply to negative 20 but add up to 1?
It's a very complicated question.
Very complicated question. What is it?
I have no idea what you said.
Okay, you know how to
My
factor these
head-
things,
My
right?
head's cut out. Yeah, I know.
It's
how to
okay.
factor.
Watch. 5, negative
Isn't
4.
it what multiplies to negative 20 but adds up to 1?
See that?
Oh, that would be
He
5.
said not subtract too.
Add up to. Yeah, they add up to 1. Yeah. So
But
this.
it's subtracting. It's subtracting technically.
Oh, it is. Yeah, you're right. Yeah, 5 plus negative 4 is technically 5 minus 4. Yes, you're right.
Let's do negative 4 plus 5.
Okay, or negative 4 plus 5, whatever. Okay, so this is a plus 5, a minus 4 is equal to 0. Okay, do you see that?
Yes.
Okay, that means A is equal to -5 or A is equal to +4. Okay?
Yes.
However, let's remember, what was A?
A was x to the 4. No, A was
X squared, right? So instead of writing A here, because what I really want is I want X, right? At the end of the day, I want X. I don't really care about A. A was just like a placeholder. So this ends up being X squared equals -5 or X squared is equal to 2, okay? What does that mean X is equal to here?
I mean, X, is it 25?
No. Something squared is -5.
Oh, something squared is -5.
Or X squared equals 4. Thank you, Bob. Thank you, Bob. Sorry. I got ahead of myself. Yeah.
What?
So-
Oh, well, that would just be 2.
No. This one will be plus or minus
That's
2.
2.
This is X equals plus or minus 2.
Yeah.
Right? Because -2 squared is 4 and +2 squared is also 4.
Is that not the one you were asking?
No. This one is actually technically imaginary. Right?
Yeah, there's nothing that does that.
Because nothing squared goes to -5. Technically, it's the square root of 5i, but like whatever.
Guys, 2.5 squared.
Yeah, it's technically this, but okay. I think it's plus or minus, but whatever. We don't really care about this one. Okay. But these are my solutions, right? X equals +2 or X equals -2, right?
Yeah.
Which is cool, because that now tells me, right, that this starts at -2 and it ends at +2, because that's where these two things intersect.
So this is like -2 is less than X and X is less than 2.
Good, exactly, yes.
Oh.
Which, when I'm doing my integral, I'm now going to integrate from -2 to 2. Okay?
Yes.
All right. The top function is the one that's on top. I know this graphically because I'm looking at it. If you ever wonder which one is on top and which one is on bottom, just plug in X equals 0 and see which one's greater. So if I plug 0 into this, right? Do you see how I get -12? But if I plug 0 into this, I get +8. That tells me this one is on top. That's the 8 minus X squared, because it's the greater function. Does that make sense, Teacup? I may have said that a little fast.
No, I get it.
Okay. So top function is 8 minus X squared, and then we do minus the bottom function. So that's minus X to the 4th plus 12, because it's a minus here. Okay? Because remember that this one was X to the 4th minus 12. So if I do minus on the whole thing, this becomes a positive. Okay?
Yes. My brain is expanding.
We're getting there, dude. We so are. Yeah, okay, cool, awesome. So this is
just
DX.
for the memes, before you go teach, can you rate actual gaming?
Oh, for a streak? I don't have that PC turned on.
Oh.
And it might mess my system up if I turn it on midstream.
Oh, just give me the password, I'll do it.
Okay. So this is -X to the 4th minus X squared. Then 8 plus 12 is plus 20. Okay. And it's the integral of this from -2 to 2. Okay. dx. Right? Okay. Now we integrate everything term by term. So we got to remember how to integrate some stuff. Do you remember how to integrate X to the 4th? What do I do with exponents when I integrate them?
When you integrate them, you raise the power and then
divide by the new power.
Or do you?
Yeah, no, you raise and you divide, right? Yeah. So this becomes -X to the 5th over 5. What is this one going to become?
I'm confused with derivatives.
What is this going to become? I know they're backwards. What is this one going to become? X squared.
It's going to be X to the 3rd over A3.
Good. And what about this one?
So 20. It's going to be 10.
Good. No. This is 20 X to the 0.
20 squared.
No. It's going to go. This goes from X to the 0 to X to the 1.
Oh dang! I'm dumb.
It's okay. So
it's 20 power with a 1.
20x. It's just 20x.
My math teacher lied to me.
It's the same. This is the same thing as 20 times x to the 1. But I'm just gonna write the x.
My kindergarten math teacher lied to me.
And then don't forget the bounds, okay? Because bounds wise, we have to go from -2 to 2. That's what these things were. Okay? This is called a definite integral because there are defined bounds on it. And so now what I'm going to do is I'm going to plug this in everywhere I see x, okay? So that's going to be negative 2 to the 5th over 5 minus 2 to the 3rd over 3 plus 20 times 2. And then I'm going to subtract that, okay, from plugging in negative 2 into it, okay? So that's going to be negative 2 to the 5th over 5 minus negative 2 to the 3rd over 3. And then this is going to be plus 20 times negative 2. Okay? Which is pretty cool, because this is actually kind of cool how this works out. You see how we have a minus here and a minus here?
Mhm.
Yeah, this is just going to make this positive, right? So we can get rid of this and say this is plus, 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 and then this thing becomes negative, but then because there's also a negative here, right, this just becomes plus. You see that?
Mhm.
Okay.
Yes.
And negative 2 to the 5th over 5, that's negative 32 over 5. Negative 2 to the 3 is negative 8, so that's going to be minus 8 over 3. And then this is going to be plus 40. Same thing here. This is negative 32 over 5 minus 8 over 3 plus 40. You see how this is it's just doubling it? It's this plus they're the same thing, right?
Mhm.
This is kind of a cool concept because these two graphs are what we say is symmetric about the y-axis, okay? Technically all I needed to do was do from here to here and then multiply it by 2.
I've been lied to.
I know. And so that kind of shows up here because these are the same things just times 2, okay? So this ends up being negative 64 over 5 minus 16 over 3 plus 80, which I'm not going to, I don't know, it's just something with, you could leave it like this, honestly. Your teacher would be fine with that, you know. I mean, you could calculate it decimal-wise, but, like, who cares? Cool. That's your answer. Does that make sense?
Yes.
Yes? Good. Woo! Oh, man. I'm tired. Oh, I still have to teach more. All right, cool. Great question, Teacup. Hope you learned something from that. I'm glad, Bob, you were watching. I'm glad you maybe learned like a cool trick there for calculus. That's pretty cool. I'll give you a bond coin as well, Bob, because like you did help out, and I appreciate you fixing my error there with the 2 squared and the 4. That's pretty cool. Bob the Goat. Yo, when do you start USC stuff, Bob? What's up? When do you have orientation and whatnot? I think this is very cool. I think Bob is one of the first students I've had in my Discord who's like gotten accepted to college, which I think is dope. Bob's been here long enough that like he was here when he wasn't in college, and now he's been accepted to college, and now he's gonna go to college, and that to me is very cool because I think ultimately that's my goal for all you guys. At the end of the day, is to make sure that you guys go to a good college and have a solid foundation in math and science so that you can pursue a STEM degree if you want. You know, just having the option is nice. Cool. All right. Okay, awesome. Thank you, everyone, for coming to office hours. I appreciate all the questions.
I think you did, like, so I was doing another capture the flag, like cryptography
Yes.
challenge, and I posted there if you want to try it. So I'm trying very hard to solve that.
Oh, wow. Okay. This is a cool looking question. We're looking for integer solutions such that one of them is prime. Oh, this is the capture the flag thing you talk about.
Yeah, so I can show you some of my progress right now. I think I'm very close to solving it.
Yeah, let me see. Yeah, show it to me.
This one.
I just got to run in 5 minutes to go teach someone.
So
also, everyone watching the stream, we'll be playing Jackbox on Saturday, so I'll make an announcement about it later today in the Discord. But tomorrow afternoon, I think works best for people. So Because I'm sorry, I won't be able to play Roblox with you guys today. I have to teach. Okay, what's up, Hypatia? Show me what you got.
Yeah, it's in the office hour channel. The first image
Yes.
is a 100-year-old paper about this, and then right now I'm just writing Mathematica to.
We love Mathematica code, dude. Mathematica code.
Figure it out.
Let's see. What does he got? What does he got? What does he got? All right, here we go. This is okay. That's cool. And then this is the cryptography thing you're doing.
Yeah.
Yeah, if you guys are wondering like about like crypto and all that stuff, like it comes from this cryptography, which is like kind of the study of puzzles and locks and mathematical things. Pretty cool. And then here is some code that he wrote. Code you wrote. Ooh, okay. Ooh, I see. Number theory. Okay, okay. Okay, we're looking for an integer solution of p to the third plus q to the third plus r to the third is equal to 1. Okay. Such that at least one p, q, or r is prime. Submit each triple at every step with the mentioned properties. Then a triple array of integers whose absolute minimum has almost 15, 35 bits. What does that mean, 15, 35 bits? What is that? What does that mean?
So it basically tells you, well, bits is like one binary digit.
Yes.
And so this number has to have at least 15 bits, which is.
Oh, but at the maximum have 35 bits.
So 2 to the 15, 2 to the 35.
Oh my god. What? Excuse me? What? That's so high.
So
2 to the 15?
2 to the 15 is
I don't even know what that number is, dude.
768, and then 2.
I don't even know my calculator can do that. I want to see if my calculator can do
2 to the 35, something very large, so not quite long, not that large.
All right, so 2 to the 15 is okay, not that bad. Okay, but 2 to the 35 is gonna be bad. Yeah, E10, 10 zeros. I think it has 10 zeros on it, dog.
Let's try the last number that I got. I think if it's correct, then yeah. Let's
see real quick what Mathematica code you did here. Okay, so you said okay, L is select range 100, prime numbers. Okay, okay. N equals 10. Okay, so these are the numbers that work: 2, 4, 10, 14, 18. Then you divide them by, oh wow, goes to hashtag 1. Then you do the prime of it. Oh man, that's a lot of numbers, man, dude. Wow, look at that. Wait, and they can be positive or negative?
Yeah, they can be either.
Oh, whose absolute minimum value is that?
It just tells you it has to be large enough in terms of the absolute value.
That's very cool. So what happens when you input this? Do you get the right answer?
I'm trying. I think I made a mistake, and yeah.
Okay. This is a cool little. Sorry, what is this? What does this mean? Integer to the 4th.
Integer to the 4th.
Is that what this 4 here means, Hypatia?
Yes. So the zeta, sorry, not zeta, c is a integer, any integer. For every integer, you give it, you take it to the 4th power, and then times 9. So
and then to the 3rd power.
Yeah, so it's kind of like a Pythagorean triple, right? Like for every integer, you are going to generate a non-trivial solution to this Diophantine equation.
Oh, very cool. For every integer. Oh man.
Yeah.
This holds for any integer. So if, for instance, if eta equals like 3, like this will hold true.
Yeah, you can try to verify it.
Oh, that's cool. That's very cool. Okay. Well, let me know how it goes, Hypatia. I have to go teach a student here in a minute.
Yeah, good luck.
But very cool. Thank you everyone for coming. Enjoyed having you guys here on the stream. We'll be back streaming regularly on Monday. That's gonna be at 3 o'clock Pacific, 5 p.m. Central, 6 p.m. Eastern. If you play Fortnite, come play Fortnite with us. We had a lot of fun last time. And we'll be doing giveaways, challenges, all sorts of things. If you found us on Twitch, join our Discord. I don't think the discord.gg link is working right now. I have to go give out some Nitro tomorrow for it to work, but this link always works. It's discord.actual.education. Join our Discord, learn with us, earn a lot of fun prizes. And otherwise, I will see you guys either tomorrow or I'll see you here at Twitch on Monday. Cool? All right.
Bye.
Peace out, guys.